Hey everybody, welcome to lesson number 4, and I'm going to begin with class example number 1. I'll leave this for you to expand and then factor. But class example number 1, 9x squared minus 16y squared. What we have here is a difference of squares, right? This is a perfect square, that's perfect square, perfect square, perfect square. So I know once I factor this, it's going to look something like this. I'll be left with 3x minus 4y and 3x plus 4y. With this example, we need to get this into a perfect square. So both of these I can factor out a 3. So I'll begin by factoring out my 3. But they also have x in common, so I can also take out an x. And they also have a y in common, so I can also factor out a y. So if I factor out 3xy from 3x cubed y, I'll be left with x squared. If I factor 3xy from 27xy, I'll be left with 9y squared. And I can factor my difference of squares here, x squared minus 9y, leaving me with 3xy, and I should be bringing my equal signs with me. 3xy times x minus 3y, x plus 3y. This last example I'll also do because these ones can be kind of tricky. So I can divide my 4's out, or factor my 4's out, leave me with 36, and then I'll have p squared q squared minus r squared. Now I have my difference of squares again. I have 4 times 6pq minus r, 6pq plus r. So I know I did that rather quickly, but what I'm doing for all of these methods is I'm trying to get my difference of squares. So there's my difference, my subtraction sign, there's my difference there, and I notice I have perfect squares, and so then I can use my difference of squares pattern. Now I'm going to be doing the same thing with class example number 2. I have my difference of squares, it looks like, is present between 49x squared and 16y squared. So we're talking about a pane of glass, and it has this area. And in this question, the length and the width of the panes can both be written in this form, ax plus by. So again, as a difference of squares. So if I have 49x squared minus 16y squared, I can write this as a difference of squares, 7x minus 4y, 7x plus 4y. And one of these represents my length, so length and width. So my length is the longer one, so that must be the one that's plus 4y, so 7x plus 4y, and that's feet. And my width would be 7x minus 4y, also in feet. Now, part B, given that the length of the plane is double the width, and the perimeter is 56 feet, develop a strategy for determining the length and width of the plane. Or sorry, not the plane, the pane. Now, 7x plus 4y is equal to, that's my length, right? And I'm told that the pane has a width that's doubled. Or sorry, the length of the pane is double the width. So this length is double the width. So if I were to multiply my width, which was 7x minus 4y by 2, that would equal my length. So that's my length, and this is my width. Now, I'm also told that the perimeter is 56. So 56 is my perimeter, and that's equal to all my sides combined. So 2 times my L plus 2 times my width. We could also write this as 2 times 7x plus 4y plus 2 times my width, which is 7x minus 4y. So these equations right here and here will come in useful. Now, what we want to do is we want to solve what my value of x is going to be, or what my value of y is. But we can do we could solve either one of those individually. If I were to solve for my value of so 7x plus 4y is equal to, so I'm going to expand this equation. So 2 times 7x is 14x minus 8y. Now, I'm also going to expand this expression here, where, if I multiply this in, I get 14x plus 8y plus 14x minus 8y, which is equal to 56. And I can cancel out those, and I'm left with 28x equals 56, and x then is equal to 2. If I plug my, if I continue with using my expressions, I know that 7x minus 12y is equal to 0, and 7 times 2 minus 12y is also equal to 0. If I rearrange this, I get 14 is equal to positive 12y, and my value of y is equal to 7 over 6. And then I can plug these in and find my length and my width of my pane of glass. So the length and the width of my pane of glass is, well, first of all, my length is equal to 7x plus 4y, or 7 times 2 plus 4 times 7 over 6. So that's going to be 14. So that's 18.66, so 18 2/3 of a foot. And my width is equal to 7x minus 4y, or 7 times 2 minus 4 times 7/6, which is equal to, well, half of that, so 18 2/3 divided by 2 would be 9 1/3 of a foot. Now let's look at class example number 3. We want to factor this completely, and if you follow this investigation here, it'll explain a different method. Well, actually, it explains substitution really well. So if you want to take a look at this, I'm going to show you the method down here. Now we're doing exactly what we did in the last lesson with substitution, where we let a equal, in this case, k squared. So if I do that, I'm going to plug in a squared minus 1. And a squared minus 1, we know, is a difference of squares. So that would give me a minus 1, a plus 1. Difference of squares, then, I can expand afterwards to k squared minus 1 and k squared plus 1. But if we look at this, I still have a difference of squares present. So I need to break this down even further to k minus 1, k plus 1, and then I have k squared plus 1. Now we can do that exact same thing with this expression right here. Before I begin, however, and actually the only difference is now I have two values I can substitute, two variables. So I'm going to say a is going to equal a squared, and I'm going to say b is equal to x squared. So before I begin, however, I'm going to divide by 5. All right, so divide by 5, and once you pull that out, you're going to be left with 5 in brackets over here, and then 5 into 80 is 16. And then I'm going to substitute my values of a squared minus b squared. All right. And I can factor further from here. 5, that's going to be 14a minus b. Or sorry, not 14, 4. 4a plus b. Again, we have a difference of squares, and that's what we're doing here. And then I can substitute my values back in. And again, I'm got to bring my equal signs down. So if I square this, I'm going to be, or if I substitute my value back in, I have 4a squared minus x squared, and then I have 4a squared plus x squared. I still have a difference of squares here, so I'll have 2a minus x, 2a plus x, and finally 4a squared plus x squared, which cannot be simplified any further. Now let's look at one of these examples. I have a squared minus b minus c. And this is actually just a difference of squares problem again. All right, so the only difference is I have two variables that kind of we could think of this as representing one variable if we want. And so you could use substitution, but you don't really have to. Now, if you're not using substitution, then just think about using your difference of squares method, where we square root this and we would get a, and we'd square root b minus c, and we could just have b minus c. But we also have, if I square root this, I'll have a plus the same terms of b minus c. Now, and I should have close my bracket there. We can get rid of some of our brackets here. And if we get rid of these brackets, I would have to distribute this negative sign in to the brackets, and same with this positive sign. So if I distribute the negative sign in, I'm going to be left with a minus b plus c. And over here, I'll be left with a plus b minus c.